The German Tiger War tank sat in the maintenance yard of the Kirov factory in Leningrad, its massive 88mm gun barrel pointed at the gray January sky. It was January 18, 1943, and senior engineer Mikhail Svirin stood before the beast with a mixture of awe and professional skepticism. For 18 months, the Red Army had been terrorized by reports of these machines, invincible monsters that shrugged off Soviet anti-tank shells, that destroyed entire tank battalions, that seemed to represent an insurmountable German technological advantage. Now finally, they had one intact. The tank had been captured 3 days earlier during the breakthrough of the Leningrad siege. A Tiger from Schwer Panzerabteilung 502 had become immobilized in soft ground near Schlisselburg, abandoned by its crew when Soviet infantry surrounded the position. It had taken 2 days and 3 heavy tractors to extract it from the frozen swamp. But the prize was worth the effort. This was only the second Tiger captured relatively intact by Soviet forces, and the first that could be brought to proper testing facilities. Comrade Svirin, Colonel Andrei Petrov of the Red Army's main auto-armored directorate approached, his breath steaming in the cold air. "You have 3 weeks to complete a full technical analysis. Comrade Stalin himself has ordered this evaluation. He wants to know, is the Tiger truly invincible, or are there weaknesses we can exploit?" Svirin nodded, his eyes never leaving the massive tank. At 56 tons, it was nearly twice the weight of a T-34. Its armor appeared immensely thick, its gun enormous compared to Soviet tank weapons. The Germans had been deploying Tigers for over a year, and each battlefield report made them sound like mechanical devils that nothing could stop. But Svirin was a trained engineer who had designed components for Soviet tanks, who understood metallurgy and mechanical systems, who knew that all machines had weaknesses. The question was whether the Tiger's weaknesses could be exploited, or whether German engineering had created something truly superior to anything the Soviet Union could produce. "We'll need to conduct firing tests," Svirin said. "I want to test our weapons against its armor from various ranges and angles. We need to understand exactly what can penetrate and what cannot." "You'll have access to the testing range at Kubinka," Petrov confirmed. "Every weapon in our arsenal, anti-tank rifles, 45mm guns, 70-60mm guns, the new 85mm. We need data, comrade engineer. Our troops need to know how to kill these machines." Over the next 2 days, Svirin's team of 20 engineers and technicians swarmed over the captured Tiger, documenting everything. They measured armor thickness at dozens of points, photographed every component, sketched mechanical systems, and cataloged German design choices. What emerged from this initial examination was a tank that was impressive in many ways, but also revealed something unexpected. Complexity. "Look at this transmission," senior technician Pavel Orlov called out from beneath the tank. "It's a Maybach HL-230, 12 cylinders, 700 horsepower. Beautiful engineering, but incredibly complex. 8 forward gears, 4 reverse. The gear ratios are optimized for the tank's weight. But comrade, this is not something that can be repaired in the field. If this transmission fails in combat, the tank is dead." Svirin climbed under to examine the transmission himself, his trained eye noting the precision machining, the quality of materials, the sophisticated design. German engineering at its finest, and therein lay a potential weakness. Precision machinery required precise maintenance, skilled technicians, proper tools, and ideal conditions. On the Eastern Front, where mud and ice and desperate combat conditions prevailed, such precision might be a liability rather than strength. "Document everything," Svirin ordered. "I want to know the maintenance requirements for every system. How often must oil be changed? What tools are required? How many man-hours to replace major components?" As his team worked, Svirin conducted his own examination of the Tiger's armor. The frontal hull was 100mm thick at 10 degrees from vertical, formidable by any standard. The turret front was even thicker at 100mm but vertical, making it vulnerable to well-aimed shots. But as he measured and documented, Svirin noticed something that made him pause. The armor quality varied. Using a simple hardness tester, he found that some sections of the frontal armor were properly hardened, while others showed inconsistencies. The side armor, 80mm thick, showed even more variation in hardness. This suggested that by January 1943, German steel quality was becoming inconsistent, likely due to shortages of key alloying materials needed for proper armor production. Comrade Svirin, Lieutenant Nina Volkova, One of the team's metallurgists approached with test results. I've analyzed samples from the armor. The steel quality is not uniform. I'm seeing variations in carbon content and hardening that suggest manufacturing under resource constraints. This isn't the quality of steel we saw in captured German tanks from 1941. Meaning what, precisely? Meaning that while the armor is thick, it's potentially brittle in places. A properly placed shot with sufficient velocity might not just penetrate. It might cause the armor to crack or spall, injuring the crew even without full penetration. This was valuable intelligence. If the Tiger's armor quality was compromised by German resource shortages, then Soviet weapons might be more effective than battlefield reports suggested. But they needed firing tests to confirm. On January 22nd, the Tiger was transported to the Kubinka Proving Ground outside Moscow, where the Red Army conducted weapons testing. The tank was positioned at various ranges, and over 3 days, Soviet weapons were fired at it systematically, a methodical dissection of its defenses. The results were simultaneously encouraging and discouraging. The 45mm anti-tank gun, standard equipment for Soviet infantry, proved utterly useless against the Tiger's frontal armor at any range. Even at point-blank range, the shells simply bounced off, leaving only paint scratches. This confirmed what soldiers had been reporting. Infantry anti-tank weapons were ineffective against Tiger's the 76mm gun, mounted in T-34 tanks and used as an anti-tank weapon, performed better, but not decisively. At ranges beyond 500 meters, it could not penetrate the Tiger's frontal armor. At 500 meters, it could penetrate the side armor, but not the front. Only at ranges under 300 meters could it reliably penetrate frontal armor, and only with precise shots at specific weak points. But the new 85mm gun, being prepared for installation and upgraded, T-34s and the new IS-1 heavy tank, proved capable of penetrating the Tiger's frontal armor at 1,000 meters with proper ammunition. This was critical intelligence. The Soviet Union had a weapon that could defeat Tigers at respectable combat ranges. However, the most interesting discovery came not from what could penetrate the Tiger, but from what the Tiger could not do. On the 4th day of testing, Svirin ordered the Tiger to be moved under its own power. The captured tank still had fuel in its tanks and was mechanically functional. German Sergeant Hans Weber, a captured tank crewman who had served on Tigers, was brought from a POW camp to operate the vehicle under guard. Weber offered better rations and treatment in exchange for cooperation, agreed to demonstrate the tank's capabilities. "Start the engine," Svirin ordered through a translator. Weber climbed into the driver's position and began the starting procedure. The Maybach engine coughed, then roared to life with a sound that spoke of power and precision engineering. But Svirin was watching the fuel consumption gauge, and what he saw troubled him. "How much fuel does this tank carry?" he asked. 540 liters, Weber replied through the translator. "But it consumes fuel very quickly. On roads we might get 100 kilometers from a full tank. Off-road in combat conditions perhaps 60 kilometers, sometimes less in mud or snow." Svirin did the calculation. 60 kilometers of operational range was catastrophically short. Soviet tanks like the T-34 could travel 300 kilometers on internal fuel, and even further with external tanks. The Tiger required constant refueling, which meant it needed a sophisticated logistics chain to support it in combat. On the fluid Eastern Front, where supply lines were often cut and fuel supplies irregular, this was a crippling weakness. "Drive it around the test range," Svirin ordered. "I want to see how it handles in winter conditions." Weber put the Tiger in gear, and immediately the tank's weight became apparent. At 56 tons, it sank into any soft ground, its wide tracks distributing the weight but still pressing deep into mud or snow. When Weber attempted to turn, the tank required enormous effort, the steering mechanism straining audibly. "The steering uses a clutch and brake system," Weber explained. "To turn, you declutch one track and brake it. This is very hard on the transmission and requires strong hands. In combat, after several hours, the driver is exhausted." Svirin noted this. Soviet tanks used lever steering, which was simpler and less tiring. The Tiger's sophisticated steering mechanism was another example of over-engineering, technically superior, but practically problematic under combat conditions. But the most dramatic demonstration of the Tiger's weaknesses came when Weber attempted to drive the tank up a modest slope covered in snow. The Tiger climbed perhaps 20 meters before its tracks began to slip. the weight causing them to dig into the snow rather than grip. Weber applied more power, the engine roared, but the tank slid sideways and stopped. "I cannot climb further," Weber admitted. "The tank is too heavy. In winter conditions or in mud, the Tiger often becomes stuck. We would need another Tiger, or sometimes two, to tow one that is immobilized." Svirin watched this demonstration with growing understanding. On paper, the Tiger was a fearsome weapon, heavy armor, powerful gun, sophisticated engineering. But in practice, it was a logistical nightmare that required perfect conditions to operate effectively, and the Eastern Front offered anything but perfect conditions. Over the next week, Svirin's team conducted endurance testing, running the Tiger continuously to see what would fail. The results were enlightening and damning. After 6 hours of operation, the transmission began overheating. German transmissions were designed for precision but not for extended operation under stress. The cooling system was adequate for German conditions, but insufficient for the prolonged operations common on the Eastern Front. After 12 hours, the first mechanical failure occurred. A final drive gear cracked, requiring replacement. This repair under shop conditions with proper tools took 6 hours. Under field conditions, it would be impossible. After 20 hours of operation, the engine began showing signs of stress. Oil consumption increased, power output decreased. The Maybach engine was powerful but delicate, requiring maintenance far beyond what Soviet engines needed. "The Germans have built a racing car, not a workhorse," Orlov observed. "It performs magnificently under ideal conditions, but it cannot sustain combat operations the way our tanks can. A T-34 can fight for days with minimal maintenance. This Tiger needs constant attention." Svirin compiled his findings into a comprehensive report. But before submitting it, he wanted to conduct one final test, a comparison with Soviet tanks under identical conditions. He requested a T-34 and a KV-1 heavy tank be brought to Kubinka for direct comparison. The comparative testing revealed stark differences in design philosophy. The T-34, weighing 26 tons, could climb slopes the Tiger could not, could traverse terrain the Tiger became stuck in, and required 1/10 the maintenance time. Its 76mm gun was inferior to the Tiger's 88mm, but its mobility and reliability meant it could be where it was needed, when it was needed. When presented with identical obstacle courses, the T-34 completed them in 15 minutes. The Tiger took 45 minutes and became stuck twice, requiring towing to continue. When ordered to fire while moving, simulating combat conditions, the T-34 maintained reasonable accuracy. The Tiger's shots were wild, its superior gun unable to compensate for the tank's rough ride and unstable gun platform when moving. When both tanks were driven 100 kilometers cross-country, the T-34 completed the distance in 4 hours with no mechanical problems. The Tiger required 7 hours, suffered 2 mechanical breakdowns requiring field repairs, and consumed so much fuel it could not have returned to its starting point without refueling. "Comrade Svirin," Petrov said after observing these tests, "you have proven something remarkable. The Tiger is not invincible. It is, in fact, deeply flawed for our conditions. But our troops need to know how to kill them when they encounter them, because in direct combat, the Tiger still has advantages." Svirin nodded. "I recommend we focus on 3 things. First, use our new 85mm guns at every opportunity. They can penetrate Tigers at ranges where Tigers cannot effectively retaliate due to their poor accuracy while moving. Second, exploit the Tiger's immobility. Attack from flanks and rear where armor is weaker. Third, and most importantly, simply survive the first encounter. Tigers cannot chase, cannot pursue, cannot operate far from their supply lines. They are defensive weapons, not offensive ones. Let them exhaust their fuel, let them break down. Let the mud and cold do what our shells sometimes cannot." The final report, submitted to Stalin and the Red Army Command in February 1943, contained detailed technical specifications, firing test results, and most importantly, tactical recommendations for defeating Tigers. But the report's conclusion was the most valuable intelligence. The German Tiger tank represents sophisticated engineering but poor practical design for Eastern Front conditions. While formidable in direct combat at range, the Tiger suffers from excessive weight, mechanical complexity, high fuel consumption, and vulnerability to terrain conditions. Soviet forces need not fear the Tiger as invincible. Rather, they should view it as a powerful but fragile weapon that can be defeated through tactics that exploit its numerous weaknesses. The challenge was getting this information to troops who had been conditioned by a year of battlefield experience to view Tigers as unstoppable. Throughout 1942, Soviet tank crews had encountered Tigers and suffered devastating defeats. T-34s would engage Tigers at what they thought were effective ranges, only to watch their shells bounce harmlessly off German armor, while 80mm rounds destroyed Soviet tanks with single hits. The psychological impact had been enormous. Many Soviet tankers had developed a fatalistic attitude when Tigers appeared. In March 1943, the Red Army's political and training departments began a systematic campaign to educate troops about the Tigers' weaknesses based on Svirin's findings. The approach was deliberately designed to rebuild confidence while providing practical tactical guidance. Training films were produced showing the Kubinka tests, with footage of Soviet weapons penetrating Tigers at specific ranges and angles. The films were careful to show both what worked and what didn't, building credibility by being honest about the Tigers' strengths while emphasizing its vulnerabilities. Technical bulletins were distributed to tank units, containing diagrams showing weak points in the Tiger's armor, the lower glacis plate, the side armor, the rear armor, the turret ring, and the vulnerable final drives. Tank commanders were taught to aim for these specific points rather than simply shooting at the Tiger's mass. Most importantly, tactical doctrine was revised to emphasize mobility and terrain exploitation. Soviet tank units were taught to engage Tigers from positions where the German tank's weight became a liability. Soft ground, slopes, forest where maneuverability mattered more than armor thickness. Junior Lieutenant Dmitry Lavrenenko commanded a T-34 company that participated in one of the first engagements to apply the new doctrine. It was May 1943 near Kursk, and his company encountered 3 Tigers defending a strategic village. Under the old tactics, Lavrenenko would have been expected to engage frontally, likely resulting in his company's destruction. Instead, he applied what he'd learned from the training films. "Do not engage frontally," he ordered his tank commanders. "Circle left through the forest. The Tigers are heavy. They cannot follow us through soft ground. We will attack their flanks from 500 meters. Aim for side armor below the turret ring." The maneuver worked. Lavrenenko's T-34s used their superior mobility to reach positions where the Tigers could not effectively respond. When they fired, their 76mm guns, previously thought inadequate, penetrated the Tigers' side armor. 2 Tigers were destroyed. The third withdrew when its crew realized they could not maneuver to engage the mobile Soviet tanks. The training films were correct, Lavrenenko reported. The Tiger is dangerous in open terrain at long range, where its gun and frontal armor are advantages, but force it into terrain where mobility matters, and it becomes a liability. We lost no tanks destroying 2 Tigers. This would have been impossible 6 months ago. Similar reports began arriving from across the front. Soviet units that had learned to exploit the Tigers' weaknesses were achieving victories that would have been unthinkable in 1942. The psychological shift was as important as the tactical one. Soviet troops no longer viewed Tigers as invincible but as defeatable, enemies with specific vulnerabilities. The Battle of Kursk in July 1943 provided the ultimate test of these lessons. Germany deployed over 140 Tigers in the offensive, intending them to be breakthrough weapons that would shatter Soviet defenses. But Soviet defensive tactics had been specifically designed to counter Tigers, incorporating everything learned from Svirin's analysis. Anti-tank positions were established in depth, with fields of fire covering terrain where Tigers would be vulnerable. Tank units were trained to engage Tigers from flanks rather than frontally. Air support was coordinated to attack Tigers when they inevitably became immobilized by mechanical failures or difficult terrain. The results vindicated Svirin's assessment. While Tigers destroyed many Soviet tanks, their superior firepower and armor meant they were dangerous in any engagement. They failed to achieve the breakthrough German planners expected. Soviet defenders exploited every weakness. Tigers that penetrated deep into Soviet defenses found themselves outmaneuvered by more mobile Soviet tanks, or became isolated when they ran out of fuel, or broke down due to mechanical failures and were destroyed by Soviet infantry with explosive charges. German records from Kursk report that of 140 Tigers deployed, only 8 remained operational by the battle's end. The rest were destroyed by enemy action or abandoned due to mechanical failure, often deep in Soviet territory where recovery was impossible. After Kursk, The Red Army's confidence in dealing with Tigers was firmly established. The tank that had terrorized Soviet forces in 1942 was now understood to be a powerful but fundamentally flawed weapon that could be defeated through proper tactics and exploitation of its weaknesses. Mikhail Zvirin continued his work analyzing captured German equipment throughout the war, but the Tiger analysis remained his most influential contribution. After the war, he wrote extensively about the philosophical differences between German and Soviet tank design, using the Tiger as his primary example. The Germans, Zvirin wrote in a 1947 technical journal, approached tank design as an engineering problem to be solved through sophistication and precision. The Tiger represents this philosophy perfectly. It is beautifully engineered, with superior individual components and impressive technical specifications. But engineering sophistication is not the same as combat effectiveness. Soviet design philosophy was different. We built tanks to be produced in quantity, maintained by semi-skilled workers, operated in terrible conditions, and repaired with simple tools in field conditions. The T-34 was not as sophisticated as the Tiger, but it was vastly more practical for actual warfare. The Tiger required 300,000 man-hours to produce. In the same time, we could build 5 T-34s. The Tiger required highly trained crews and skilled mechanics. The T-34 could be operated and maintained by hastily trained conscripts. The Tiger needed perfect conditions to perform optimally. The T-34 fought effectively in mud, snow, dust, and temperatures from 40 to plus 40 Celsius. In the end, Germany produced 1,347 Tigers during the entire war. The Soviet Union produced over 57,000 T-34s. This disparity tells you everything about which design philosophy was correct for industrial warfare. The Germans built beautiful machines. We built weapons that won the war. This analysis became influential in post-war Soviet military thinking and in how other nations approached tank design. The consensus emerged that while the Tiger had been a formidable weapon, it represented a fundamentally flawed approach to armored warfare, prioritizing individual vehicle superiority over the practical requirements of mass production, maintainability, and operational sustainability. The captured Tiger, tested by Zvirin's team in 1943, survived the war and is now displayed at the Kubinka Tank Museum outside Moscow, where it stands as a monument to both German engineering prowess and its limitations. The firing test results, the technical analysis, and the tactical recommendations that emerged from testing this single tank influenced Soviet military doctrine for decades and contributed materially to Germany's defeat on the Eastern Front. For Soviet tank crews who had faced Tigers in 1942, the knowledge that these seemingly invincible machines had critical weaknesses was psychologically transformative. They learned that the Tiger's thick armor could be circumvented by mobility and tactics, that its powerful gun was compromised by poor accuracy when moving, that its mechanical complexity made it vulnerable to breakdown, and that its excessive weight made it a prisoner of terrain. The Tiger I remains legendary in military history, one of World War II's most famous tanks, symbol of German armored power. But Zvirin's analysis revealed a deeper truth: that impressive engineering specifications do not automatically translate to combat superiority, that practical considerations matter more than theoretical performance, and that in war, the weapon that can be mass-produced, easily maintained, and reliably operated under terrible conditions will ultimately triumph over the weapon that is technically superior but practically limited. The Soviet engineers who tested that captured Tiger couldn't believe its weakness, not because the tank lacked strengths, but because those strengths came at such operational costs that they undermined the Tiger's effectiveness as a combat weapon. In the brutal arithmetic of the Eastern Front, where battles lasted days, where terrain was terrible, where logistics were primitive, and where quantity mattered as much as quality, the Tiger's sophistication became its greatest weakness. It was a racing car on a dirt track, a precision instrument in a mud fight, a beautiful machine in a war where beauty was irrelevant and only effectiveness mattered. The Tiger's legend persists because it was indeed formidable in direct combat. Its thick armor and powerful gun made it feared by any opponent. But legend and reality are different things. The reality, documented meticulously by Soviet engineers in 1943, was that the Tiger was a flawed weapon that could be defeated, that its reputation exceeded its capabilities, and that German engineering brilliance had produced a tank that was simultaneously impressive and inadequate. a machine that looked invincible but concealed weaknesses that would contribute to Germany's defeat.